Okay, last class we stop here. So let's see where we solve the problems that related to the electrical energy supply in life. So first, we use the biogas sources to generate electricity. So biogas is a gas that is highly flammable, and they are produced when the organic matter such as cow dung decays. Cow dung means that the shit lah. Okay. So in a biogas reactor, the cow dung will be collected and placed into a biogas fermentation tank. Because of during the fermentation, you will release the biogas. So the biogas will be used to run a generator in a combustion engine to produce the electricity. Okay, they will use it to how to say, the gas will be used to boil the water. So the bottled water will become water vapor and spin the generator, and the generator will, after the generator rotate, it will start to generate electricity. Okay. All right. Second, building a hydroelectric generator in a river. So power station that use the river water to generate the power normally depends on the rapidity. It means that how fast, how fierce the flow of the water flowing through the river. So they will build a water mill across a rapidly flowing river, and the water well will turn the turbine in turns to spin the dynamo. Okay, because the water will spin this I mean the what you call that, this water mill, and this one will spin the generator is the turbine is dynamo inside. So with this, the electricity will be generated. This is normally used in those small villages in normally the European country. Okay, where the electricity is not that easy to get because it's not easy to, like, maybe it's far away from the generator, I mean the big generator or this, so they will sometimes use this kind of way to generate a small power which is enough for them to use. Okay, now how about other innovation? First, the roof with solar cell. Okay, so the roof with the solar cell will absorb and change the solar energy. Wait. And they will change the solar energy to electrical energy without affect the environment. While at the same time, the wireless electrical transmission and distribution. So some changes on electrical energy to radio wave or microwave energy, so that it can transmit it to the and distribute without wire to electrical devices. So then the electrical devices will change the radio wave or microwave energy back into electrical energy. Okay, this is the so-called wireless, what you call? So-called the wireless charger or the MagSafe, something like that. Okay. All right. So these are 6.1. Wait. Your school now until which chapter? Not yet. Means I forget already because. Chapter 2. All right. Actually, it's been so long. They're still in chapter 2. So quite surprisingly. Where Oh, they haven't teach yet. Why your school now lack of teacher, is it? Oh, well, yeah. Okay, can you see the questions clearly? Yeah. Okay, so try to do the questions. I already got the questions. I just realized. Use this one. Easier. Done, huh? All right. So let's continue the answer. So what's mean by the renewable energy sources and non-renewable energy sources? So renewable energy sources are energy sources that can be replaced continually, means that it can continuously replace and will not depleted. While non-renewable energy sources are energy sources that cannot be replaced and will deplete. So figure 1 shows tree arrangement PQR and with moving or stationary magnet and the coil of wire. So P, the coil remains stationary, magnet move. Q, the what I call that, the coil move towards the magnet, and R, both coil and magnet remain stationary. So which one light up? So the arrangement P and Q will be light up. Why? Because the magnetic field line are cut by the coil of wire to produce induced current. And the induced current flow through the LED, causing the LED to light up. And in which arrangement does the LED not light up? R. Why? Because there's no cutting of magnetic field lines and no induced current flow through the LED. So what's the functions of CRO? Is to show the shape of graph, direction of current and voltage change for direct current and alternating current. Okay? Okay, huh? You do it correctly, huh? All right, so let's continue. Now let's continue with a transformer. Wait, So a transformer is a device that changes the voltage of an alternating current. So where it's made up of a soft iron core with a coil of insulated wire on both sides of the core. You see, it's like the soft iron, okay? The middle one is a soft iron, then with two coil of wire. So when the alternating current is flow through the primary coil, so when there's a current flow in, so the coil now will become magnetized. So a changing magnetic field is created continuously. It will be magnetized. Magnetized, so the what you call, because it's alternating current, so the direction of the magnet, what you call that, the electromagnet line will be like moving around. So when it's moving around, like it's like the magnet is moving, is moving in the coil. So this coil will cut through the magnet and induce current. So the changing magnetic field will induce an alternating voltage in the secondary coil and the bulb will turn on. Can you understand what I'm trying to say? Can I? So it's like this. So it's an alternating current, right? So it will be like first, okay, it will be like this. So first, there will be a electromagnetic current comes out, and this will cut by the coil, correct? Then this is on positive side. When on the negative side, you see the direction of the body. So when the direction from like this to like this, so it will be another cut through again, correct? So this will create an induced current. Okay. Now, so for primary coil, this one, the left side, normally on the left side, it receives input voltage, means that there will be a current that comes in, while secondary coil is produce the output voltage, input, output. And the voltage that produced, which is the output voltage, can either increase or decrease, where it depends on your input voltage and also the numbers of turns of the primary and secondary coil. So in a transformer, the voltage is larger on the side with more turn. Means that normally, if input is more turn, then the input voltage will be higher. If the input voltage turn is less than the output coil turn, numbers of turn of output, that means that the output voltage will be higher than the input voltage. It actually depends which one has the more turn of the wire coil. Okay. All right. So this is the, and these are lead to step up and step down transformer. So this is the step up one. For step up transformer, you can see the secondary coil turn is more than the primary coil turn. So the primary voltage, okay, input across the primary coil is lower than the secondary voltage, okay, across the secondary coil, because the numbers of turn of the primary coil is less than the secondary coil. So the normally if the secondary coil has more than primary coil, then it's a step up transformer. Means that the voltage will be making the output voltage is higher than the input voltage. Step down is where the body means that it's opposite. So the primary voltage is higher than the secondary voltage, which is output. So the numbers of turn of the primary coil is more than the one in the secondary coil. So you see the symbol, you can see from the symbol, if the output is longer, so means that it's a step-up transformer. If the primary coil is bigger, so means that it's a step-up down transformer. Okay? Can All right, now let's see. So a step-up transformer has more turn of wire on the secondary coil than the primary coil, while a step-down transformer has less turn of wire on the secondary coil than the primary coil, like we said. So like I said, the numbers of turn of wire in the primary and secondary coil will determine the output voltage. So step-up transformer have more turns of wire on the secondary coil, so it produces a higher voltage. Step-down transformer, less turns of wire on the secondary coil, so produce lower voltage. Okay, so this is how. Okay, so this is the how we should looks like. All right, now let's see the transformer equation. So the ratio, wait. Okay, now the ratio of this primary coil to the secondary coil is equal to the ratio of numbers of turn of primary coil to the numbers of turn of the secondary coil in the transformer. So this is the formula. The primary voltage divided by secondary voltage is equals to the primary coil turn divided by secondary coil turn. Okay, so this is the equation. And in Malaysia, the supply voltage of alternating current normally is 240 volt. Okay, not normally. Domestic use is 240 volt. Of course, if for industrial, doesn't necessary. I think industrial, we have a 33 kilowatt, means that 33,000 watt. And then we have a 13,000 watt. We have a, I forget already, 6,000, something like that. There are a lot of different level. It actually depends on what kind of application we're going to use. Okay. So you see, for this one, this one, the figure shows that 40 watt bulb connected to a 240 watt power supply through a transformer. So this is the one. So find out the numbers of turn of the secondary coil that is required for the bulb to light up at normal brightness. So try to calculate this one. Okay. You see, he gives you this, he gives you this, he gives you this. You need to find this. So use the formula just now. Okay. Done, let me know. Okay, done, huh? All right, so let's see the answer. So you see, it light up in a normal brightness if it's supplied with the voltage of 40 ma. So V secondary is 40, primary voltage is 240, numbers of turn in primary coil is 120. Fill in the formula. So you get, okay, rearrange, you get your NS is 20. So your numbers of turn in the secondary coil should be 20. So is it correct? You do it correctly? Okay. You wait me for there's someone looking for me. Okay, you do it correctly for this one? Yes, huh? So now let's continue with the next one. So diagram below, it shows 12 what you call 12 volt bulb connected to a 240 volt, okay, source through a transformer. So what should be the numbers of turn in the secondary coil if for this 12 bulb to light up? Okay, so it's almost the same way lah. So try to do this as well. Okay, all right. Okay, so let's continue with the next one. So you see, so it lights up. So we just calculate with the input voltage VP primary is 240, output voltage VS is 12 volt, and MP is 120. Substitute all this into the formula, rearrange, you will get your NS is 6. So the numbers of turns for the secondary coil will be only 6 turns. So you read correctly? Okay, good. Now let's continue. Okay, try to do this one. Wait, I think maybe I have to wait. Give me a second, Okay, try to do the questions. Can you see this clearly? Can you see the question clearly? Yes, good. Okay, so 我们来看一下 let's see the answer 啊。So first, what is a transformer? So a transformer is a device that can change the voltage of an alternating current. So underline the correct answer. So transformer only function using alternating current. So in a step-down transformer, why only alternating current? Because only alternating current will have positive and negative value. So the direction of the what you call the electromagnetic line will change. If direct current, they will only produce a single direction, what you call single direction magnetic line. So the induced current will not able to carry out because it becomes constant. Okay, so in a step-down transformer, the numbers of turn of in the primary coil is more than the one in secondary coil. So step-up transformer is used to change used to change 25 kilowatt to 250 kilowatt. So step-down transformer is fixed in a radio because radio only use a small voltage. So you need a step-down transformer to turn down the value. Okay. Okay. So far correct. Okay. Now, state one example of home electrical appliances which uses the following type of transformer. So for step-up transformer like microwave, okay, washing machine, refrigerator, television, air condition, and electrical stove. Normally, those with high power usage one, you will need a step-up transformer. While for step-down transformer, it's like your charger, phone charger, laptop charger, tablet charger, all this. Okay. Now, figure shows the transformer in a 5-volt mobile phone charger connected to the 240-volt main power supply. While figure B shows a circuit diagram, this one, circuit diagram of the transformer in the mobile phone charger. So it wants you to calculate the numbers of coil in the primary one. So you see 240 over 5 equals to NP over 10. So this one moves here, you will get 480 turns. Correct? You do it correctly? Okay, now, is the transformer in the mobile phone charger a step up or step down transformer? And then explain the answer. So the transformer in the mobile phone charger is a step down transformer. Why? Because the output voltage is lower than the input voltage. And the numbers of turn in the secondary coil is less than the numbers of turn in the primary coil. Something like that. Okay. All right. So now, so let's continue with okay, so let's see the distribution of okay, so let's see the transmission and distribution of electricity. Now, the component that involved in the electrical power transmission and distribution will be power station, step-up transformer, then these are the national grid network, and then transmission substation, there are substation, oh sorry, then a step-down transformer, okay, before enter your domestic. Okay, so these are the one. Okay, we have power station, then go to a step-up transformer, went up to national grid. Okay, and then we go to this one is we have these are the transmission system lah. Okay, involved what you call the step down transformer. This is step down transformer, and then back to a distribution system, then from substation to others, something like that. Okay. So normally they will have a something like a step down transformer from all the places, then go to the national grid and then step up a bit to the kilang, all this. Okay, like that. Okay, it's actually just sound what I show here. All right, so generators at a power station, they will produce an alternating current with a voltage of 11 kV or 25 kilowatt. Then they will enter a transformer station. By using a step-up transformer, they will raise the voltage to 132 kilowatt or sometimes 275 kilowatt. Okay, then the current then will enter then the alternating current will flow through a network of transmission cable like all these are. These are the national grid network. Normally they will flow through the big one first. This one with the tower or pylon. These are the high voltage transmission line. Before they go to the step down, and then step down again to before go to domestic. So at the end of the grid, the alternating current will flow to a switch zone at the main substation. So this switch zone will enable the electricity to be sent to the branch substation when needed. Okay, these are the switch zone, and these are the substation. So the switch zone also used to enable the specific power station and grid to be closed for maintenance work without disrupt the electricity supply to the consumer. Normally, they comes up with two sets of equipment. One is the what I call the main equipment. The other one as the backup when they are doing the maintenance job. So there were this why they call the switch zone because they can switch over. Okay, so at the main substation and branch substation, the alternating current will be going through a series of step-down transformer at the step-down transformer station. So the voltage will go reduce gradually to different voltage value to be supplied to consumer according to their needs. So normally it's like what I say 13 kilowatt normally is for the industrial one. Then they will undergo a small one. You see the pylon with a small step down transformer on top. That one normally is the one for well connected to the domestic use. Okay, can you understand? Okay, so these are the things that we have just now mentioned. I've already mentioned. So it's just the same thing. So now let's see the electricity supply and wiring system in home. So in our home, we are using alternating current with a voltage of 240 volts supplied to our homes by the live wire. So the current is returned to the substation by neutral wire. So there are two types of electrical wiring system. We call single phase and three phase. So the single phase and three phase so let's see the difference in single phase and three phase are actually it's actually in the front of your home. Normally you will see wait, I'm trying to see whether is there any no, there's no two phase. They are either single or three phase. Okay, let's see this one single phase and three phase wait. You see, these are the wait so this is single phase, and this is a three phase. The most easiest thing you can see is from the outside, the meter normally only comes out with one fuse. The big fuse is single phase. This one comes out with three fuse. You see 1, 2, and 3. This is three-phase one. Okay, you understand? That's the most significant difference. So let's see how the difference is. So for a single phase wiring, they are only suitable and stable enough for electricity usage, which is not exceed 10 kilowatt or 15 ampere. Normally is in the rural residential area. While these are, you see, they have only one phase. So if three phase means that there are three incoming power system. You see, so you can see the what you call you can see from peak to peak. Okay, the gap is very small. Unlike this one from peak to peak, the gap is very big. So normally this one you see means that the power is more stable here. So this one is normally for commercial and industrial area where electricity usage is more than 10 kilowatt or 50 ampere. So that's why we need a three-phase wiring because it's more stable and reliable. Okay, but sometimes some of the house that they did design for three-phase, some design mostly are single phase but some of them are three-phase. Like my house are three-phase. Okay. So normally this is the single phase, this is a three-phase, but nowadays mostly a three-phase one. Okay. So now this is the supply of electrical energy and home electrical wiring system, where we have a live wire carrying the power in, and then they will enter this one is the external wall, the power meter, straight away enter power meter. Okay, then enter main switch. This one starting from here and circuit breaker are this one, the boxes. This one is the outside one, the outside unit, we call the external unit. Then they will enter the main switch. From main switch, they go to circuit breaker. These are the circuit breaker. Okay, and then some circuit breaker will go to fuse box and go to some of the lamp, all this. Some of them are connected straight away to the socket and power circuit, and then back to earth wire. Earth wire is used to, like, they will divert the extra and electric to underground to prevent short circuit. And some of them, okay, this is because you see our power need to back and forth now, correct? So this one is back, this one is forth. You see, the neutral wire is to go back to the power system, the national grid. Okay, can you understand? All right, so maybe this one I have to use the what you call. Maybe I have to use your textbook because your textbook shows much more clearer picture. So you see the electrical. These are the sources. So the electrical wire from the main cable, the one that on the roadside, which is on the pylon, are connected to homes and made up of live wire at the red color wire is live wire at 240 volt and neutral wire of 0 volt because it's for back one. So then we go with a main fuse box with one main fuse. Normally, if you are using three-phase, then they have main fuse box with three main fuse. Okay, then they go to a electric meter. Then from electric meter, they will go to a consumer unit, the white color unit. Just I saw the plastic box. Normally, your house, inside your house, at your living room, you will saw one white color box. So we have main switch, the one that when there is any electric shock, or any something wrong, the one that you will switch up, that one is the main switch. They control the total current flow through the circuit in the house. Then we have ELCB, the earth leaking circuit breaker. So when there's too much current flow through it, so they will break the circuit. This is the one that when there's lightning, so they will stop the power supply. This is the one. And we have an MCB, miniature circuit breaker, the one that separates the final circuit with the so that it can go to different electrical appliances, which is the distribution. Okay, normally for distribution. Okay, give me a second. Okay. Oh yeah. Yes. Anything you want to ask? So, oh yeah. Okay. Now let's continue. Okay. Then we have a. Then we have these three. You see from. Okay. So after all these circuit, you see from here to here, they were connected to this. We call the lightning circuit. This lightning circuit, okay, is the one lighting circuit is the one that we use for your, I mean, the lamp in your maybe your living area, your living room, your what you call that, your dome, not dome, your bedroom, all this. Okay, that's why they need to be parallel because each light has their own switch. Okay. Okay, then we have something that from here, there's also what you call. There's also something like this, which is the power circuit made up of live wire, neutral wire, and earth wire. These are the sockets that we use. That way we put the what you call the charger inside to charge your phone. All these are the socket. Okay, so with this in okay, they combine. Okay, form this. All right, so now let's continue with the components. We have fuse box where it protects the house circuit from damage, okay, caused by a large current or overloading. Then we have main switch, which controls the amount of current which flow through the circuit into the house. Circuit breaker, it breaks the circuit, okay, by springing out for or trip the switch when current flow through exceed the rating. So this is where like when there is something wrong with your appliances, or sometimes the what you call there's a lightning struck, so too much power, too much current, so it will spring out, or we call tripping. Okay, so we have a live wire that carry the current with a voltage of 240 from local substation to home. Then we have neutral wire return, like I said, back and forth. So the return is you return the current from home to substation so that it becomes a complete circuit. Earth wire, it connects the appliances directly to earth as a safety measure. So normally the one with socket, 3-pin socket normally comes with earth wire. But some of the China made one, they might just ignore the earth one and they just show just for show one. Electric meter record the how much energy we use, electrical energy that has been used. Okay, so this looks like the switch. This is the fuses, ELCB, the earth leakage circuit breaker. We have an MCB, the miniature circuit breaker. We have an earth wire that connected to the LAN one later on. And we have a lightning conductor. This one, when the lightning strikes here, the power, the energy, the electric will be directed into the ground through the earth, together with the earth wire also directed to the ground as well. Okay. There's color. Okay, now let's see the 3-pin plug. Okay, so there are electrical appliances like electric kettles, irons. They obtain the electricity from socket on the wall through the three-pin plug. Three-pin plug means that the plug with three pin. While two-pin is like hair dryer, your electric toothbrushes, the small power one, they normally use the two-pin plug. The only difference between three-pin and two-pin is three-pin involve the what I call that the earth wire. Two-pin only live wire and neutral wire. Okay, so you see the inside. For live wire, normally red color or brown color wire. Then for earth wire, either yellow and green stripe, while the neutral wire normally are the blue wire. So these are actually is the main electricity cable which contain 2 or 3 inner wire, and each of them with a core copper. This one core copper, because copper is a good conductor of electricity. And the outer layer are flexible plastic. Why? Because they are plastics are a good electrical insulator and it's cheap. Okay. So let's see the color code for each of them. So the wiring color code is important. Why? Because without the color, sometimes you see we don't know the wire is for live, neutral, or earth. So we need the international color code to differentiate them. So normally for live wire is brown color, neutral is blue, earth is yellow with green stripe. Normally that. But sometimes the brown color can be substituted by the red color. Earth wire sometimes with green wire. Okay, so any questions? No, All right, I think I will stop here for today, I think. Okay, so we shall meet each other on next class. Okay, and you haven't sent me your result. Please WhatsApp me your result. Every single marks for every subject. Okay, I just use it for reference only. Don't worry. Okay. If wrong wire in wrong place, it will directly short circuit the whole the power. So somehow your just now the MCB, you remember the circuit breaker. The circuit breaker will spring up, means that it will how to say, we cause tripping, so that is a protection method so that your other appliances won't affected. Okay. All right. I think I will stop here for today. So see you on next class. Bye bye. All right. Bye bye.